Hey everybody, here we are still in day 2. We're going to go over sections 2, 3, and 2, 4 today. We're going to look at more graphs for quantitative data. So let's get started. Okay, so today we're going to look at constructing stem and leaf plots, constructing dot plots, and time series plots. The stem and leaf plots are a simple way to display small data sets. In a stem and leaf plot, the rightmost digit is the leaf and the leftmost digits remaining are the stems. So in this case 14.8, this would be the leaf, this would be the stems. Over here, if I have 2,739, this would be the leaf and this would be the stem. Now I will say sometimes people will round the numbers and cut off the zeros so that they can do stem and leaf plots and then put a key at the bottom. But for right now, we're just going to stick with what they're telling us. Okay, so here we have U.S. Census Bureau projection, percentage of population age 65 and over for each state and the District of Columbia. Construct a stem and leaf plot. So first thing we're going to do, as we did before, is look for the smallest number. So we want to take a look and figure out what the smallest number is. So far it looks like Alaska, and I'm going to continue to go through and see if I have anything that's less than 8.1. Utah has 9. So it looks like 8.1 is the smallest. Then I want to see what my highest number is. It looks to me like all my numbers are still in the teens. I don't see anything that's over 20. I see 15. I see 17.8 in Florida. Looks like that's going to be my highest number. So 8.1 Alaska and 17.1 in Florida. So I know that I'm going to start with my number 8 and I'm going to go to 17. Now, same as before when I told you, when you're looking at a stem and leaf plot, you don't want to have too many, well, we'll call them columns here. Now, if you turn a stem and leaf plot on its side, you can see it makes a histogram. Okay, so that's something that people often point out, is that a stem and leaf plot on its side is a histogram. Now, and I take a look at my leaves or my decimal points for this problem, I'm going to take my decimal points and I order them from smallest to biggest. Now, first they just put the numbers wherever, and then over here they order them from smallest to biggest. This would not be correct. This is correct, okay? So this was just like your scratch paper to get them all sorted out. And then over here, you're going to order them smallest to largest for the leaves. Okay? And this is important because you can use a stem and leaf plot to find your mean, median, and mode. And if they're not in order, then that becomes a problem. And that's something we'll be looking at in another chapter or so. Alright, so we have two data sets that have similar values. Sometimes we can do a back-to-back stem and leaf plot. So here we have course averages in an English class. Here we have course averages in a history class. So we see that their smallest number here looks like it is around the 40s. And my highest number is 100. So as I take a look at this, I'm going to go through and I can put my English class. I have 45, then 57, then 62, 66. And it is quite helpful if the numbers are already in order, because then you can just go straight down. You don't have to just line them up and then organize them later. So these are already in order, so that's a huge help. So I have my English class here. Now I'm going to jump over to my history class, and it goes in the opposite direction. So this is 59, 61, 67, 71, 71, 73. So very important that you're going from inside out. Inside out. Okay? Now we'll take a look at dot plots. So here is data which says the number of children that are had by each of the presidents and their wives. We have 3 rows of data here. So here we have 3 rows of data. And this tells you how many children they had. 0, 2, 10, 2, 5, etc. Next line, 4, 5, 3, 2. I first looked at this and I was like, I wasn't sure why they had this as purple, gray, and purple, but no relevance, just to show you that there's 3 different rows here. So now I see that the smallest number, 0 children, the largest number, 15 children. Okay, so I'm going to go from 0 to, they decided 16 in this one. You could go to 15 if you wanted to and cut it off here and have all of your 1 values. That would be fine as well. Okay, so here I have my number line. Again, notice that the scale between the numbers, if I'm going by 2s, is this same. Very important when you're graphing to make sure that your scale is the same so that it is not misleading. Now I'm going to count how many zeros do I have. 1, 2, 3, 4, 5, 6. So I put 1, 2, 3, 4, 5, 6 dots here. Okay, and then go along, and that is how you can make your dot plot. And that can give you a good idea of where data is concentrated at and where there's gaps. Obviously, there's pretty big gaps up here. Not too many presidents had 10 or 15 children, but a lot of them had between 2 and 4 children. And I was kind of surprised at how many had 0. Now constructing a time series plot. Time series plot is used when data consists of values of a variable measured at different points in time. In a time series plot, the horizontal axis represents the time and the vertical axis represents the value of what we are measuring. So here we have the Dow Jones Industrial Average at the end of each year from 2003 to 2016. Here are your averages. Notice the bottom again, similar to a histogram where it's a continuous with the numbers. And then starting here, again, making sure that you have the same width from 0 to 2000, 2 to 4, 4 to 6. Again, very important that we have the same width for our scales. Then you're going to, at each point here for each year, now sometimes they'll put a little line segment here on the line so you know exactly where you need to go up and put your point for your number that it represents. And then connecting all of them together will give you your time series plot display. Now, if you take a look at your graphing calculator, I wanted to show you because it seemed like last time I wasn't sure whether or not you were aware of where it says to make your list at on your graphing calculator. So if you hit second, L1 is down here at the number 1. Okay, so there's L1. So whenever you're bringing it up, it's there. All right, now we want to put things in a list. So in order to do that, then I'm going to say math, edit. Okay, so when I edit, now I'm going to have my list 1, list 2, list 3, list 4, list 5. This is where I'm going to put all these numbers here, starting with 2003. I'm going to list all these numbers, then I'm going to list their corresponding numbers that go with it. After I do that, after I enter my values into my L1 and my L2, again, this is L1, this is L2, then I'm going to hit second and Y equals, and it'll take me to this screen. And when I'm on this screen, I want to press 1 to access plot 1 menu. So I press 1. And what I need to do here is make sure that I turn it on. Select on in the line graph plot. So I want to make sure it's on. See up here, if it was over on this side, it would be off, but I want to make sure that it's on. Now, if you used it before you put it on, it might still be on, but you want to check that. And then you want to make sure that you choose your line graph. So I'm going to go over here and I'm going to select my line graph. I have my X list is my L1, my Y list is L2, and then I can decide how I want my marks to be down here. And the color of my graph. After I do that, I'm going to press zoom 9. Now I don't have the data in there, so it's not going to come up. But when you press zoom 9, you will then get this graph right here. Okay, so you should know how to do a stem and leaf plot, and don't forget the back-to-back stem and leaf plots, which go from inside out, the dot plots, and the time series plots, and that will be 2.3. And now we're going to go to 2.4. 2.4 is very important, talks about how many graphs can be misleading. You'll see this if you start paying attention to commercials all the time. There's these misleading graphs that the media will use. So let's take a look. Understand how improper positioning of the vertical scale can be misleading. We're going to understand how the area principle for constructing statistical graphs, and we're going to understand how three-dimensional graphs can be misleading. Okay, statistical graphs, again, when properly used, can be powerful forms of communication. Unfortunately, when they are improperly used, they can misrepresent the data and lead people to draw incorrect conclusions. Here we discuss 3 of the most common forms of misrepresentation. The first one, incorrect position on the vertical scale, incorrect sizing of the graphical images, and misleading perspective for three-dimensional diagrams. Let's look at the improper positioning of the vertical scale. Notice here, these two graphs are measuring the same thing. Passenger traffic at Denver International Airport, 2009 to 2015. The difference is this one is starting at 0 and going to 60. And this one is starting at 47 and going to 55. Now you can see how different these look. Over here, it doesn't look like there's that much of a difference. But over here, because I didn't start with 0, my differences are quite exaggerated because I'm not in proportion with how long from 47, which is right here, down is included. So you have to watch for that. Now, another thing that I've seen, and they used to teach us to show the kids in high school, is if you wanted to start at a different number, you'd put a little squiggle line in between. You'd have a 0 and then a squiggle line and then 47. And that would indicate that it is not proportional. However, when you're just looking at these representations, it's still misleading. So it's not a good practice to use. Here's the same graph as a time series plot. You can see again, there's really not much of a difference if you have it this way. But when you're looking at this, then that could really give you a misleading picture of what's going on. Now let's look at the principle for constructing statistical graphs. The area principle says that if you're going to build shapes to represent amounts, those shapes should be proportional to the amounts when they're differences. In other words, if I have a number that is twice as big as another number, the picture should be twice as big as the other number. So let's take a look at examples. Here we have the cost of jet fuel in 2012, and then It had fallen in 2016 to 93 cents. So note that 2016 is about 1/3 of the price in 2012. If I have this here and I cut it into thirds, I can see that this bar graph is a good representation of the drop. I start with 0 and it's about 1/3 of the way. However, if I look at the picture, this definitely looks like it's smaller than 1/3. The problem is it took 1/3 of the length and width, but also of the height. So instead of it being 1/3 bit smaller, it's now 1/9 the size because it's two-dimensional. And if you decreased it 1/3 by both dimensions, then 1/3 times 1/3 is 1/9. So this would not be a good representation of what it should look like. Now, three-dimensional graphs also can be misleading because if you're looking from the top, it can give you quite a biased position of how big the graphs are. You could see that the very top of the graphs, they kind of look like they're the same. Well, that really doesn't matter because these are bar graphs, okay? And we were saying that the widths in a bar graph don't matter. Now, what we want to compare is the height. So, unfortunately, to make the top of the bars visible, these are usually drawn so that the reader's looking down on them, and it makes the bars look much shorter than they really are. So, three-dimensional graphs can be misleading. Now, the common ways that graphs can be misleading, in summary, you can have the incorrect position on the vertical axes. You can have incorrect sizing of the graphical images. And you can have three-dimensional graphs that might distort the perspective. And that is all for 2.3 and 2.4. So I will talk to you soon. Have a good night and peace.